Hey everyone, yeah, we'll still be dealing with the continuation of hexadecimal. In our last class, we talked about the addition in hexadecimal and subtraction in hexadecimal. And before we talk about the addition and subtraction in hexadecimal, the first thing we really talked about was you understanding what hexadecimal is. And I said the hexadecimal itself comprises of what? 16 digits, which are 0 to F, whereby the value of A is 10. Where the value of A is 10, the value of B is 11, the value of C is 12, the value of D is 13, the value of E is 14, and the value of F is 15. So today we'll be dealing with multiplications in hexadecimal. We'll be dealing with multiplications in hexadecimal. So firstly, we'll be dealing with the first example. So if we're having BC base 16 times D base 16. Let's start from there. Let's start picking it one after the other. Solution. So what do you think we're going to do? That's BC base 16 multiplied by D base 16. What is the value of C? C is 12. So 12, and what's the value of D? D is 13. So what are we going to say? The first thing is 12. That is, this is 13. 13 multiplied by 12. So we'll make use of our calculator. 13 multiplied by 12. Then we are going to have 156. So the value of this 156 is greater than the base. So 156 divided by 16. 156 divided by 16. What are we going to have here? We have a 9 remainder. So who can tell me what the remainder will be? Remainder 12. 9 remainder 12. So what is our 12? 12 is what? Is C. So the next thing we are going to say D, which is 13, multiplied by B, which is 11. 13 multiplied by 11, 13 multiplied by 11. That's 143. So 143 divided by 16. So that's 8 remainder. So you say 8 times 16. 8 multiplied by 16. That's 128. So 143 minus 128, and we're going to have 15. That is 8 remainder 15. So what is our 15? Our 15 is F, and we are having 8. And we draw the 8 here, base 16. The way you understand that. Okay, good. Let's go to the example 2. So example 2. Maybe if we are dealing with the process of having, let's say we are dealing with BC multiplied by AD. Base 16, base 16. How we go to go? So don't forget 13 multiplied by 12. So that's 156. 156 divided by 16, that's 9 remainder 12. So what is 12? Our 12 is C. Then we write 9. We keep 9. So D multiplied by B. So what's our D? That's 13 multiplied by 11. So what are we going to have? 13 multiplied by 11, that's 143. 143 plus 9. That's 152. 152. So 152 divided by 16. What do you think we're going to have? That's 9 remainder. One 52 divided by 16. That's 9 remainder. Eight. Then we're going to drop the 9 back. Do we get that? Now let's move to this one. A, which is 10. 10 multiplied by C. 10 multiplied by C. That's 10 times 12. That's 120. 120 divided by 16. We are having 7. So 7. So that's 7 times 16. 7 times 16. Then 120 minus 112. That's 8. So 7 remainder 8. So we write 8, we keep our 7. So then A is 10. 10 multiplied by 11. So that's 110. 110 plus 7, that's what? 117. So 117 divided by 16. What are we going to have here? We're having 7 remainder. So 16 times 7, that's 112. 2. So 117 minus 112, we were having 5. So that's 7 remainder 5. So then we're going to keep our 7 here, and we're going to drop our 7. So let's add them together. So then we're going to have C. We put the base just. Then here, what are we going to have here? We are going to be having 8 plus 8. 8 plus 8 is 16. So 16, it is up to the base. So what are we going to do? So that will be what? 16 divided by 16. So 16 divided by 16 will be what? 1, remainder 0. So that's 1, remainder 0. So we're going to write 0, we keep 1. So 1 plus 9, that's 10. 10 plus 5, that's 15. 15 is not up to the base. And what's 15? That's F. Then we're going to drop our 7. So we're having 7F, 0, C, base 16. Then we get that. So I really want us to try others or form any other examples by ourselves. So apart from this hexadecimal, one other thing I would just really have to chip in is to convert the conversion of bicimals. That is the conversion of decimal numbers to bicimals. So we're going to start with that. So I really want you guys to form different examples and solve these. And you can also drop anything on the comment section. If you feel you don't understand this, just drop that. Then I will make another video concerning this by doing other examples under this hexadecimal. So one more thing we're going to treat right now is the conversion of decimals, to bicimals. So what does it mean by that? Maybe for example number 1, if I'm having 1 over 4, they can say convert, example 1, they can say convert 1 over 4 base 10 to bicimals, that is to base 2. You can say to base 2. Then we get that. So the first thing I will have to just do here is very, very simple. 1 over 4. So I will convert this 1 over 4. Since it's a proper fraction, so I'll convert it to a decimal in form of decimal point. So 1 divided by 4, that's 0.25 base 10. So what am I going to do? The next step I'm going to do right now is 0. This point, I'll write it under here, and I'll write 25. Like this, 0.25. Because I'm converting to base 2, I'll multiply by 2. So what happened? 2 multiplied by 5, that's 10. Right? 0, keep 1. 2 times 2, 4 plus 1, that's 5. I'll withdraw and I'll write 0. Now, why am I writing 0 here? Is because the answer I got here is a 2-digit number. That's why I'm writing 0. So that is the 3rd digit number here is 0. So I'm breaking it out. Now let's move. Let's multiply by 2. Here 2 times 0 is 2. 2 times 5 is 10. If I write 10, you can see it's a 3-digit number. So I'll have to bring the last digit outside. So instead of writing 1 here, I'll draw an arrow outside and I'll write my 1 here. So what will I have? So what does it mean by that? It means that the answer to this question itself is what? That is, the conversion of 1 over 4 base 10 is equals to what? 0.01 base 2. Do we get that? So it is not only compulsory that we only convert to base 10, we can convert to base 5. So if we are converting to base 5, you will just be multiplying by 5 instead of 2. If you are converting to base 7, you multiply by 7. If you are converting to base 16, you multiply by 16. Do we get that? So that's how that works. So I'll solve one more example on this. So let us just say if we're having 5 whole number 6 over 8 base 10, let's convert to base 3. Let's use that as an example. So now you can see that this is a mixed fraction. Yeah. So that is, what does it mean by that? That is, if it happens that you are having an improper fraction, you convert that improper fraction to a mixed fraction. Do we get that? So, but if it is in terms of a proper fraction, you just divide direct and you have your number. So what does it mean by that? Solution. I used to tell my students something that if we have 1/1/2, it's still the same thing as what? 1 plus 1/2. It's still the same thing. So if I'm having 5/6/8, it's still the same thing. That is, if I'm having 5/6/8 base 10, it's still the same thing as what? 5 plus 6/8 base 10. So that is, everybody will now carry his own base 10. So what's the first thing I will have to do? I'll first take this 5 base 10. I'll convert it to what? Base 3 first. So what will I do? 3. 5 divided by 3. That will be what? 1, remainder 2. Did we get that? And I'm going to drop 3. 1 divided by 3, that's 0, remainder 1. So all together here, what will I be having? I'll be having 12 base 3. 1, 2 is 3. So we are not done. So I will come back to this man, which is 6/8. 6/8 base 10. So I'll convert that to, because now you can see that this man is what? A proper fraction. So I'll convert 6 divided by 8. I'll be having 0.75 base 10. So in the process of dealing with 0.75, the next thing I will have to do is what? The 0.75, 0.75. So I'll multiply by what? Base 3, which is 3. Don't forget this is a 2-digit. So if it comprises of 3 digits, I bring the third number here. So 3 times 5 is 15, right? 5. Keep 1. 3 times 7 is 21. 21 plus 1, that's what? 22. That's 2, and you bring 2. Multiply again by 3. 3 times 5 is 15, right? 5. Keep 1. 3 times 2, 6 plus 1. What will you have? 7. What will I bring here? 0. Multiply by 3. 3 times 5, 15, right? 5. Keep 1. 3 times 7, 21 plus this 22, right? To keep 2. It will always be giving me a repetition. You know, it started from 7.5, 2.5, 7.5. The next one is also 2.5. So I will just have to stop here. So I'll be having what? 0.202 base what? Base 3. But I'm not done, because the questions here, when I split it, I said 5 base 10 plus this. So my 5 base 10, what did I have here? So that will be 12 base what? 12 base 3 plus 0.202 base 3. So 12 plus 0, what will you have? That will be 12.202 base 3. Do we understand? Please, I really want you to like, you share, and you subscribe. Please, if you don't understand anything, drop it on the comment section. Thank you.